Hello everyone, welcome to my YouTube channel. In this video, I'm going to explain about the concept of laser trip alarm and its possible implementation as the home security system. So let's get into the video. This is basically the concept of the laser trip alarm. So as you can see, we have an LDR in series with a 1 kilo ohm resistor and a laser diode which points its laser onto the LDR. So initially, when the laser is made to hit on the LDR, this LDR is basically a light dependent resistor. It provides lesser resistance. Lesser resistance means less voltage drop at LDR and more voltage drop at 1 kilo ohm resistor. Therefore, the terminal voltage at terminal A would be high when there is any interruption in the path of the laser. For that moment, this resistance at the LDR would increase since it is not exposed to light in the form of laser. So more resistance means more voltage drop at LDR and less voltage drop at 1 kilo ohm resistor. Therefore, the terminal A voltage would be less. So this terminal A voltage is given as a signal to ESP32, and based upon this signal, the ESP32 will know that the laser is tripped or not, that is, its path is blocked or not. So this is the concept of the laser trip alarm.
As you can see, this is the circuit setup of the laser trip alarm. So we have an ESP32 powered by the USB-B cable and a piezo buzzer connected to the ESP32, and this is the LDR and connected in series with a resistor. So instead of a resistor, I used a potentiometer since we can adjust the sensitivity. So as you can see, the laser is falling on the LDR. So whenever there is an interruption in this path, the laser, this ESP32 will turn on the alarm and will ring the piezo buzzer. So currently this RGB LED, this is an RGB LED, so this indicates the state of the laser alarm. So it is an off mode. So we can control the state of the alarm using the Blynk IOT app. Not only the ESP32 will trigger this alarm and will send the state to Blynk IoT app, it will also trigger a webhook service by which we get a SMS in our mobile phone. So we have to specify the mobile phone number, we will get the SMS. So that is done possible using the IFTTT app. So now let us go to the laser.
Now coming on to the laser setup. So we have a laser diode powered by the DC wall adapter, and the laser emitted from the laser diode is made to reflect onto multiple mirrors and create a pattern, and finally reflected onto the LDR. So the pattern is as follows. So from the laser diode, the laser is emitted onto this first mirror, and from the first it is reflected onto the second, and from that onto the third, onto the fourth, the fifth, and finally onto the LDR present in the laser alarm circuit. So this pattern is created so that interruption of any trip line will prevent the laser from hitting the LDR. So let's say I'm preventing this trip line from the third to the fourth. Okay, I'm tripping it, so you can see it is not hitting the LDR. I'm moving, you can see it is hitting the LDR. So not only this, I can trip here, I can trip on the bottom, and still you can see it is preventing the laser from here on hitting the LDR. So this creates a pattern and will make sure that no one enters into this premise without triggering the alarm. So that is the basic setup of this laser alarm system.
So the messaging setup is basically made possible using the IFTTT app by creating webhook with Android SMS setup. So this is basically the IFTTT website. So let me show you the applets that I have created. So as you can see, this is the applet. So basically I have done an applet with a webhook and an Android SMS types applet. So basically webhook is something that whenever we go to the particular URL, some action should happen. That action is basically this Android SMS. So basically this is the applet that I created, so I'll just show you. So basically this is the trigger service. The trigger service is a webhook, and then an action would occur, that is the SMS. So we can control the turning on and off the laser trip alarm using the Blynk app or the Blynk website. So currently I'm recording it in my phone, so I'll control it using the Blynk website. So this is the device name, laser alarm. So with this I can control the off and on state of the laser trip alarm. So I'm turning it on. I'm sorry. Now you can see it is in on state. So when in off state, nothing happens when we trip the alarm. So I'll show you. Nothing happens. But in on state, when there's any interruption in the path of the laser, let me say I'm blocking the laser here, we still would get a siren turned on and also a message to our phone. Now I am turning it off. See, it is off. Now again on for resetting it. So now the siren won't go on unless there's an interruption. So when there's an interruption, we get message in our phone.
The circuit diagram and the code are available in the description below, so do check it out if you want to try by yourself. And I've coded this entire setup in Micropython, and Micropython, there are many tutorials available in the YouTube, so check out if you want to get familiarized with it, because it is very convenient to code in Micropython compared to the Arduino C language. And yeah. So the drawbacks that I consider in this setup is that we can't verify when we get a trip message that it actually an intruder is entering or it is a false trip that occurred due to an insect flying in the laser line or a dust falling. But although I have kept this alarm setup on for 1 week and I haven't received any false triggers, only I have received triggers when a person enters into the premise, but still we can't actually be 100% sure. So in that case, I plan on to adding a camera setup in the future, so that whenever the trip occurs, we also get a photo of the entrance with which we can identify the trip is a false trip or an actual intruder entering. So this is how I plan to innovate this project. But this current setup can be used with a CCTV camera that can be viewed using a smartphone. So whenever we get a trip signal stating that there is an intruder entering, we can always verify it using the CCTV camera that can be viewed in a smartphone. So that is the current use case of this system. So many new innovations in this current project and also new projects would be carried out in this YouTube channel. So do consider supporting me. And thank you. Have a nice day.